So let's talk about some more interactions of Earth systems. And yesterday we looked at the water cycle, and we're going to see kind of some more effects of that water cycle, but we're going to see how it interacts with the atmosphere. So we're going to look at changes in the atmosphere in particular, but we'll see how the atmosphere interacts with the hydrosphere and the geosphere. And you can kind of see already, we can see a lot of different changes going on in this picture in our atmosphere. And these changes all or mostly occur in the troposphere. If you remember, troposphere, the word from the word tropos, which means turn or change, because that's exactly what's happening in this layer. And you can see this is the definite boundary here between the troposphere down at the bottom and the stratosphere at the top half. So tropos change, there's lots of changes happening in our atmosphere, and sometimes these changes can happen within hours or even minutes. We over the summer had a number of big storms come in, and I had been working outside, and you could just see the weather, the change moving towards you. And this happens all over the earth like this. So there's lots of changes going on in our atmosphere all the time. Some are gradual, some are nearly instant, but we want to look at these changes. One of the changes is known as weather. Weather is the state of the atmosphere at a certain time and place. You're more than likely very familiar with the word weather and the concept, but here's kind of our textbook definition. That's what we're talking about when we talk about weather. We're talking about what's going on in the atmosphere here and now, or what's the atmosphere going to be like tomorrow or for the next week or so. And we know there's all different things that count as weather. When we pull up the weather app on our phone, or we watch the weather on the news, or go to a weather website, or look at it in a newspaper, some of you don't even know what I'm talking about because you're so young, but newspapers often have the weather in them. There are certain things that we're talking about, certain conditions that we're looking for when we look at the weather. And one of the first, just ignore that, one of the first conditions that we look at has to do with these numbers here. We talk about the high and the low. We're talking about the temperature. The temperature. The temperature is the measure of the average amount of energy produced by the motion of air molecules. So when we look at a thermostat in our house, or we take our temperature, what we're doing is really measuring the amount of energy in the molecules within our body or within the air around us. And so that's exactly what heat is. It's a form of energy. So when we take the temperature, we're measuring the amount of heat. Another thing that we look at is precipitation. And we actually talked about this in the water cycle. Precipitation is moisture that falls from the clouds to Earth's surface. And it can take place in the form of rain or snow or sleet or hail or freezing rain, and it happens in different amounts in different areas. Here we have this is North Carolina here, and we are in this kind of yellow area, kind of getting into the green. And if you say that's not right, that's fine. I'm colorblind, but we're right about here. So whatever this is, but you can see there's different amounts of rainfall and different types of rainfall happening, or precipitation happening. Then we look at atmospheric pressure. Let's look at what the actual word pressure means first. Pressure is the force exerted over an area. So there's lots of different things that can cause pressure, but in particular, when we look at the weather, we're looking at air pressure. And air pressure is the force exerted by air molecules in all directions. So when we're talking about the pressure for weather, we're talking about atmospheric pressure. So In higher altitudes, you have lower air pressure because there's less air above you. So if you are, for instance, on Mount Everest, there's less air above you weighing down on you. Now, when you're at sea level, you have the accumulation of all of the air molecules in this area above you. So the most air pressure that you're going to have is down here at these lower altitudes. So there's a lot more air above you when you're down around sea level. So the air pressure is high. The next condition we look at is wind. This is a wind sock here. We will measure wind speed, we'll measure gusts and things like that, direction of the wind. It's kind of important when it comes to weather. And that has to do with air pressure because wind is the movement of air caused by differences in air pressure. So when we get into when you get into 7th grade, I believe you talk more about weather, but you'll learn about air currents and things like that that are caused by differences in that air pressure. Because looking at this picture, it's not all the same everywhere that you go. This is just kind of an average, and when we measure air pressure, we're only measuring it in one place in particular. So the average is about 1 atmosphere of pressure, but it may not be the same over here, and it's definitely not the same here. So this difference in air pressure causes the movement of air, and that's wind. That's what we feel. And so scientists will measure that when they look at the weather, and it has an effect. We know that it'll move clouds, it'll push rain, it'll do all kinds of different things. So we're very concerned with what the wind can do. Then we also look at humidity, and you can look at this picture and almost feel it. You can feel kind of how sticky your skin gets. And so humidity is actually the amount of water vapor in a given volume of air. So we will measure how much water vapor is in the air around us. We know where we live not far from the ocean, and we have a lot of rivers and lakes and swamps around us. So in the summer months in particular, it gets very humid here. If you live down in Florida, also very humid there. So you can actually feel how much humidity is in the air. And if you live someplace like Arizona or someplace near the desert, there's a lot less humidity, and so you can feel how dry the air is. And so when we think about the weather, we want to know what kind of humidity are we going to have that day. Another important part of the weather is visibility. So we want to know what is the distance at which an object or light can be clearly discerned. So it's important when you're driving to know what kind of visibility we have. The last few days it's been very foggy in the morning, and so there's been very low visibility. And then one of the last one we'll look at is actually the UV index. UV index. Now the UV index is the measure of ultraviolet radiation at a certain time and place. So here, this is a UV index chart for New York City. Now, remember we talked about how the sun gives off radiation, and there's different types. There's UVA, UVB, and UVC. Now, the ozone layer will block out a lot of the UVC, but we also want to know about these other ones because they can be harmful to our skin. It can be as simple as sunburn, or it can be as severe as skin cancer. So we're concerned, what kind of UV radiation are we looking at in a particular area? Do I need to cover up? Do I need sunscreen? And so this will also have an impact on our weather. Now, the second type of change that we see in the atmosphere is climate. And here we have different types of climates. Climate is the average weather pattern for a region over a long period of time. So think about it this way. We can look up the weather for Wendell tomorrow, or even for the next week, and it can change and it can do this. But when we talk about climate, we're talking about what does that weather do over 30 years. And that's 30 years is usually the average of time that they'll examine weather patterns in order to establish what type of climate it is. And so there's different types of climates all over the world, and there's a lot of different factors that affect these climates. We'll look at two in particular here. One has to do with geography, mountain ranges. So there's what's called the rain shadow effect, and this happens near the ocean where there's mountains, and we actually experience this here somewhat, not as severe as on the west coast, but it's called orographic lifting. You don't really need to know that. But so the air flows and it brings moist air, warm moist air off of the ocean towards a mountain range, and it cools as it comes off of the coast, and so that moisture in the air, so it's the wet side, the windward side, that moisture in the air as it raises up on the mountain will begin to cool and condense. So it will rain on this side of the mountain, so it's a lot more wet climate. But then as the air passes over the mountain, it's let off a lot of that moisture here, and you'll get some on this side of the mountain, a little bit, but not much. And so as it moves out, you're in what's called the rain shadow, and so there's a lot drier on this side of the mountain. And then finally, ocean currents will also affect the climate. You see they carry warm water and air, and you can see here's some of the different ocean currents that we have, and you can see how they affect the climate in different parts of the world.